Hi, it's Carly McAvoy. This is a review for the midterm exam. So if you don't think you need this review, then you don't need to watch the videos. Translating, simplifying fraction, categorizing numbers, absolute value, and properties of real numbers will be covered on this video. We're starting off with translating. I just wanted to remind you, if you have something that says 12 less than z, then it's z that comes first. Because you're saying we want 12 less than that. If you want 12 less than my age, you have to know my age before you can take 12 away from that, right? So 12 less than z is z minus 12. It would have to say 12 is less than z before we had an inequality there. Okay, second is simplifying fractions. Remember that if you want to add and subtract fractions, you need to rewrite those with a common denominator. 7, 3, and 21 all go into 21, so I would do 7 times 3 and get 21, and 1 times 3 and get 3. The 5 over 21 wouldn't change, and 3 times 7 here I would get 21, and 2 times 7 is 14. So if I add those together first, I get 3 and 5 is 8, and then I subtract 14. 8 minus 14 is 6, negative 6. So that's going to be negative 6 over 21. But then always you have to reduce your fractions to lowest terms. And 3 goes into both of these. So if I divide by 3, I get negative 2/7. That would be the lowest term for those two fractions. So remember, a common denominator for fractions. Any of these that you're having trouble with, you should go back and watch the original videos where we spend a little more time. Then you have asked to categorize numbers. Remember we talked about whole numbers, natural numbers, integers, rationals, irrationals, and real numbers. Every number in this set is a real number. Real numbers we can write with that symbol that has basically 2 lines and an R. That's the symbol for real numbers. So what is 1/4? Well, 1/4 is not a natural number. Those are the numbers we count with. It's not a whole number. Whole numbers are natural numbers plus 0. It's not an integers. Integers are just the opposites or the negatives of the whole numbers. It is a rational number because rational numbers are where decimals and fractions come in. So this is rational. If it's rational, it cannot be irrational, one or the other, but it's also a real number. What about negative 7? It's not a number we count with. It's not a number we count with plus 0. It is an integer. That is the opposite of the whole numbers. So it's an integer. It's a rational, because rational are all the integers, whole numbers, naturals, plus decimals and fractions. And it's not an irrational. If it's a rational, it can't be both. And then it's also a real number. What about 0? Well, it's not something we count with, but here is when we start including 0. So it's a whole number, it's an integer. Integers are whole numbers and their opposites. 0 doesn't really have an opposite, but it's still an integer. And then rational numbers, because it includes all of the naturals and whole numbers and integers, decimals and fractions. In rationals, again, it can only be in one of these two categories, so it's not irrational, and it's real because real number are all of those. What about pi? Well, pi is not natural, whole, an integer. It's not rational because rational numbers end if you put them as a decimal or repeat. And this irrational is what that is. Irrational numbers, if they were written as a decimal, would never repeat and never end. It's always a real. All those are real. And then 13 over 13. Well, 13 over 13 is just 1 in disguise. So that means it's all those things. We do count with it. It's natural. Then it's included in the whole numbers. It's included in the integers. It's included in the rationals. Then it's not included in the irrational, and it is real. That would be the same for the square root of 16 while we're at it. The square root of 16 is 4, and that would have all the same things. It's a natural number, it's a whole number, it's an integer, it's a rational, and it's a real. But what about negative 1/3? Well, negative 1/3 is nothing we count with. That only includes the 0. It's not the opposite of a whole number, but it is a rational number. And it's not irrational because if we divide that out, it repeats. It either has to end or repeat. And this one repeats as 0.33333, or negative, I should say. And then it's a real number. So that's the categories. We went into those in more detail in an earlier video. Feel free to go back and check that out. What about absolute value? When you see two lines, straight lines like this on either side of a number, it's asking you to find the absolute value. Absolute value is a number's distance from 0. So the absolute value of -5, we're saying how far is -5 from 0. We don't care if it's left or right. But the absolute value is 5. It's 5 units away. The absolute value of 2, well, it's 2 units away. And they're asking you to compare those two, and 5 is obviously greater than 2. Take the absolute value first before you compare. Identify the property used in the following. If we multiply something by 0 and we get 0, that's the 0 property of multiplication. If we add something, 0 plus something, we get still itself. That's the identity property. If I did 1 times x equals x, that's the multiplicative identity. This is the additive identity. 0, if we add something to 0, it doesn't change its identity. If we multiply by 1, it doesn't change its identity. What about x plus y plus z equals x plus z plus y? What I did here was I changed the order of the two terms that are in the parentheses. That means I'm looking at the commutative property. Commutative property says you can change the order without changing the answer. Here I did x plus y plus z, x plus y plus z. Look, I didn't change the order. Commutative is about changing the order. Here I did not change the order, but I changed the grouping. I grouped y with z here, but y with x over here. That's the associative property. The associative property changes the grouping, but not the order. And what about this? A times b minus c is equal to ab minus ac. Well, that is the distributive property. And finally, one of the things you'll have to be able to do on your midterm, and I think on your final as well, is simplify something using the distributive property. This says -1/5 times x minus -1/5 times 2/3. That minus sign in the middle is here. Well, that's going to give me -1/5 x. And then you see how I have two negatives? That makes that a plus. And then I have 2 over 15. I'm just multiplying straight across 1 times 2 and 3 times 5. All right, that's it. Have a fantastic day.